Now that you have a clear Azure logging strategy for what to log, where to store it, and how long to retain it, you are ready to turn logs into something leaders and operations teams actually benefit from: observability. Logging gives you evidence, but observability gives you understanding. Observability is how you move from "we have data somewhere" to "we can detect issues early, explain what happened, and improve systems continuously." Your goal in this lecture is to design an observability architecture that works in real enterprises, where multiple teams ship workloads, incidents happen under pressure, and leaders demand answers fast. With that context set, you need a definition that is stronger than monitoring. Observability means you can understand the internal state of your services through the signals they produce, and you can answer questions you did not anticipate when you first designed the system. In an enterprise, observability is not only about charts, it is about accountability, operational confidence, and the ability to reduce downtime over time. Leaders care because observability reduces business disruption and helps teams respond faster. Architects care because observability validates whether architecture decisions are producing the intended outcomes in production. With observability defined, you now position Azure Monitor and Log Analytics as foundational building blocks in your platform layer. Azure Monitor is the umbrella capability for collecting and acting on telemetry, while Log Analytics provides a structured place to query and analyze logs and related signals at scale. In leadership terms, these tools enable truth at speed, meaning the organization can quickly see what is happening and make decisions based on evidence. In architectural terms, they provide a consistent platform for telemetry collection, analysis, alerting, and reporting across many subscriptions and teams. With the building blocks introduced, you now clarify the signals your observability architecture must handle, because each signal serves a different purpose. Metrics provide fast, numeric indicators of health and performance, such as latency, error rates, and resource saturation. Logs provide detailed events and context, such as authentication outcomes, configuration changes, and application errors. Traces connect events across distributed systems, so you can follow a single request through multiple services. You are not collecting these signals for vanity dashboards. You are collecting them so you can detect problems early, investigate quickly, and improve reliability systematically. With signals understood, you now address the reality leaders and architects face. Observability often fails because organizations collect enormous amounts of data, but still cannot answer basic questions during incidents. This happens when telemetry is inconsistent across teams, naming conventions are chaotic, alerts are noisy, and ownership is unclear. The result is alert fatigue, slow incident response, and leaders losing confidence in operational readiness. Your architecture must therefore prioritize clarity over volume, and it must create standard patterns so data becomes useful rather than overwhelming. With the problem clear, you now design the workspace strategy, because this is where observability becomes governable. You decide how many log analytics workspaces you need and how they map to organizational boundaries like production versus non-production, business domains, and regulatory separation. Too many workspaces create fragmentation, inconsistent queries, and duplication of effort. Too few workspaces can create access control challenges and cost confusion. Your leadership objective is to balance central visibility with controlled access, and your architectural objective is to make investigation and reporting consistent across the enterprise. With workspace strategy introduced, you now focus on the leadership pattern that makes it work. Central visibility with controlled access. Security operations and platform operations need enterprise-wide visibility to detect systemic issues and respond to incidents. At the same time, teams need appropriate access boundaries, so sensitive logs are protected and least privilege is maintained. Your design therefore treats observability as a shared enterprise service, where central teams have cross-cutting visibility, while product teams have the visibility they need for their services, without creating open access to everything. With access patterns clear, you now make collection consistent because inconsistency is the enemy of enterprise operations. You define standard telemetry expectations for platforms and workloads, including baseline logs, key metrics, and application insights signals where applicable. You also define naming conventions and required metadata such as environment, system name, service owner, and business criticality. Leaders care because standardization reduces incident time and improves audit readiness. Architects care because standard collection validates architecture patterns consistently rather than leaving observability to individual team maturity. With collection standardized, you now design alerting as a leadership system, not a technical configuration. Effective alerting is about sending the right signal to the right team with the right urgency. You define severity levels that map to business impact. You define thresholds that align with service level expectations. And you define clear ownership for response. An alert without an owner is noise. An alert that cannot be acted on is waste. Leaders care because alerting directly affects downtime and customer impact. Architects care because alert design reflects understanding of system behavior and dependency chains. With alerting principles set, you now address alert fatigue because it is one of the fastest ways to destroy operational effectiveness. Alert fatigue happens when systems produce too many low-value alerts or when alerts are not tuned to real service impact. Your observability architecture must treat alert reduction as a quality goal. You prioritize high signal alerts tied to user experience, error rates, and critical dependencies. You also define escalation pathways so that important alerts are not lost in the noise. Leaders value this because it improves response quality. Architects value it because it aligns monitoring with real service outcomes. With alerting quality addressed, you now discuss dashboards because dashboards are often misunderstood. Dashboards are not a replacement for good alerting, and they are not meant for everyone to look at all day. You design dashboards for different audiences. Leaders need service health summaries, trend visibility, and risk indicators tied to business outcomes. Operators need deep technical dashboards that show dependency health, performance patterns, and operational workload. When you separate dashboard audiences, you reduce confusion and increase trust because each audience gets what they actually need. With dashboards defined, you now focus on correlation because this is where observability becomes truly powerful. During incidents, the question is rarely, is something broken? The question is, what changed, what failed first, and what is the fastest safe path to restore? Correlation means you can connect identity events, control plane changes, application errors, and network activity into a coherent timeline. Leaders care because correlation reduces downtime and improves crisis communication. Architects care because correlation reveals systemic weaknesses and helps improve reference architecture patterns. With correlation in mind, you now extend observability into change management because many incidents are change related. Your architecture uses telemetry to validate changes, detect abnormal behavior quickly after releases, and support safe rollback decisions. You design the environment so that major changes are observable by default, and you can answer whether a new deployment caused performance degradation or whether an external dependency failed. Leaders care because this reduces business disruption. Architects care because it creates a feedback loop where architecture choices are tested against real-world results. With change visibility established, you now address observability costs because telemetry can become expensive if unmanaged. Your design includes Cost governance principles such as tiered retention, purposeful collection, and clear ownership of telemetry costs. Leaders care because observability must deliver value without uncontrolled spending. Architects care because cost discipline encourages thoughtful design. You collect what you need for outcomes, not everything because it is possible. When cost is governed, observability remains sustainable at enterprise scale. With cost governed, you now define the operational model because observability only works when responsibilities are clear. Platform teams typically own the observability platform, baseline, workspace strategy, and enterprise standards. Application teams own instrumentation quality, service dashboards, and first-line response for their workloads. Security operations teams consume telemetry for detection and investigation and contribute requirements for identity and security signals. Leaders care because accountability reduces downtime and blame cycles. Architects care because clear ownership keeps the platform consistent while allowing service-specific observability to mature. With ownership clear, you now bring this to life with a scenario that leaders recognize instantly. Imagine a customer portal starts timing out during peak hours. In a weak observability model, teams argue about whether it is the network, the database, or the application, and leadership receives inconsistent updates. In a strong Azure Monitor and log analytics design, you quickly correlate metrics showing increased latency, logs showing a dependency error, and control plane events showing a configuration change earlier in the day. The right team receives a high severity alert with clear context. Rollback happens quickly, and leadership gets a single evidence-based narrative. This is what observability that works looks like in practice. Let's now discuss the key takeaways from what you learned so far, so you can design an observability architecture that leaders trust and operators can rely on. Observability turns raw logs into operational understanding, enabling faster detection, clearer incident narratives, and continuous improvement. Azure Monitor and Log Analytics are platform layer building blocks that support consistent telemetry collection, analysis, alerting, and reporting across the enterprise. A working architecture balances metrics, logs, and traces, and prioritizes clarity over data volume. Log Analytic workspace strategy must scale, avoiding fragmentation while supporting controlled access. Collection must be standardized. Alerting must map to severity and ownership. And alert fatigue must be actively reduced through high signal design. Dashboards must be designed for audiences. Correlation must connect signals into one story. And observability must support change validation to prevent outages. Cost governance and clear operational ownership make observability sustainable and accountable at scale. If you want your Azure environment to be observable in a way that reduces downtime and increases leadership confidence, subscribe so you can continue through the rest of this playlist and complete the enterprise architecture journey. Like this video so more leaders and architects learn how to design observability that actually works. Comment with your biggest observability challenge such as workspace strategy, alert fatigue, or cross-team ownership, and share this with your team so you can align on one observability architecture and respond to incidents with evidence instead of guesswork.